Hi everyone, hope you are doing well. I'm Reza, founder of the optimizationcity.com. In this film, we are talking about the simple shortest path problem for loopless network and solve an example for this problem. Let's move on.
The shortest path. Shortest path is a special case of the minimum cost flow problem. What is the shortest path? In the real world, the network theory finds a practical application determining the shortest path within a network. In this context, network consists of an area and a region that as a node, and the combination paths connecting them are known as an arc. Any node in this network can be considered either a starting point or a destination. The objective is to define a path between the origin and destination that results in the shortest distance, known as the shortest path within a network. The network covered in this course can categorize into two sections: loopless network and the loop network. In the upcoming section, we will explore each of these networks in more detail, examine their characteristic, property, and application. We start with the loopless network. Loopless networks are similar to the basic network, but in this case, both nodes can act as an arc and can act as an origin destination node for movement. In the simple shortest path method, computation begin from the origin node and continue toward the destination node. During this computation, each node is assigned as a code M that represents the shortest path from the starting node. The starting node is assumed to have a number of 1, and the end node is the number of n, and the intermediate nodes are sequentially numbered. The algorithm for the loopless network for shortest path problem as follows. In step 1, we start by setting the code of the starting node to 0. M1 is equal to 0. In step 2, calculate the code of node j, which is mj, using the following equation, where S is a set of nodes that lead to node j, and dij represents the direct distance between node I and j. In step 3, once the code of the end node is determined, it represents the shortest path distance between the starting node and the end node in the network. To find in step 4, to find the shortest path, we employ the backtracking method. We will discuss in the example what is this method. Let's apply the method we find to just learn the shortest path problem from node 1 to 8 in this directed network. The distance between each pair of nodes are indicated as a number above the arc. We can find the shortest path method from node 1 to 8 in the given network using the method we discussed. We start from the code of node 1 as the M1 is equal to 0. We calculate the code for node 2 by adding the M1 plus 4 is equal to node 2. M2 is equal to 4. Moving on to node 3, we have two paths to reach this node. We need to consider the both paths. We have path 1 from this is the path 1 and this is the path 2. So M3, we have the two options for calculating the M3. 0 plus M2 plus 1 is equal to M. M1 plus 3 is equal to 3. The minimum value of the 3 and 5 is equal to 3. So M3 is equal to 3. We continue to this calculation for the other node, and we have the calculation for 8th node in this figure, and we can see that the shortest path from node 1 to 8 is equal to 12. In order to determine the shortest path between node 1 to 8, we use the backtracking method. This involved checking each node j, for example, that meet the condition mi is equal mj minus dij, which help us to identify the node along the shortest path. We start the process from node end node and explore the three branch to connect to this. So we get back here. This is the shortest path. We have the two shortest paths. We start from the node 8. 12 minus 3 is equal to 9. So the arc 5, 8 is on the shortest path. So 9 minus 5 is equal to 4. So arc 2, 5 is on the shortest path. Here 12 minus 5 is equal to 7. So it's on the path. 7 minus 6 is not equal to 4, so it's not on the path. 7 minus 2 is equal to 5 is on the path. 12 minus 7 is not 9, is not on the path. 9 minus 4 is equal to 5 is on the path. So it's not, we can eliminate this path. It's not important because we have the other path. So also 5 minus 2 is equal to 3 on the path, and 5 minus 6 is not 0, is not on the path. So we check the all shortest path to find um, the different option we can move from 1 to 8. We don't consider this path because this is not in the path. So if we find out that the arc 7, 8 is not on the shortest path, we do not consider this path. Okay, by backtracking, by this method, backtracking method, we can find the own shortest path from 1 to 8. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by form by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much and goodbye for now.